Welcome back, welcome back, welcome back, welcome back, welcome back. Welcome back to another of our video on Centroid. At the end of this video, you should know how to graphically find the centroid for a complex shape. In this case, we have a figure which can be broken out into three parts. We have one section here, another section here, section B, and we have section C. Now, section A is a regular rectangle, while section B is a, what's this, a trapezium, or is a parallelogram? Yeah. While this is a rectangle, or this is a quadrilateral. Quadrilateral. Now, the first step is to draw lines from here through to here, from this point through to that point, and next line from here through to this point. So this object is symmetrical, so the centroid will fall someplace along here. So the centroid for this one is right here, is here, which is quite obvious. And the centroid for this section, I'm gonna join here, then draw the centroid for this part. So I'm drawing two diagonal lines. And again, the centroid for this piece is right. No, well, let this piece stay. Well, that is that, yeah. Now, for this particular one, the method that I'll be using is I will be extending the base. I'll be transferring the distance from here, this distance down here. So this is 20. I'm marking 20 here. Oh, so here is 20 actually. And then I'll be transferring this this distance down here, and then this distance up here. So this is 1 point. All right, so probably I should transfer, well, it's the same thing eventually. So then I'm gonna transfer this distance and the other side up here on this line up here. So this is 40, transferring 40 here. So let me extend this to that. So the principle behind this is that the principle here is that for this method, I simply extend this. Well, let me extend this there and extend this here. So I transfer this distance here, then transfer this distance up here, then draw a line across and went through the center. This gives us a centroid. So this is the same principle I'll be applying to this part. So here, so let me go ahead and probably should use red to mark that. Now let me get my ruler. So I'll be marking off the 4. This is 40. So I'll be transferring 40 on this line right here, 40, which is right here. So I'll be joining this point to down here. And the center will be here. Centroid is here. So the centroid for this, for B, is here, and the centroid for this part is here. So we have two separate pieces. I need to separate. I need to use a line to separate this. So we have one piece here, another piece here, and another piece down here. So we know of all three centroid for all three pieces, which is right here. Now, to find the centroid for these two combined, we need to apply a formula. The formula is that the area of, we need to establish a ratio. Formula is the ratio of this side to that side. So ratio of A, ratio of A versus ratio, establish a ratio between A and B. So area of A, area of B. Whatever we get, we divide the distance between both centroid by that portion, then distribute it accordingly. So in this case, we have, I think I have some working out here. Now, so here for here, so we have the maths here, which I did in advance. So area A, which is here, is length times width, which is 80, which is 80 by 10, which is 80, this area. And this one is area 2 is this is area 2 is this distance plus this distance divided by 2 times this distance, which is 80. So we find the average between these two to get that, and then multiply that by the height to get the area for this. So that works out to 20 plus 40 over 2 times 80 gives us 2,400. So now when we establish a ratio between A and B, ratio between A and B, if A is 800, section B is 2,400, the ratio is then 1/3. Yeah, so you need to divide this from here to here into 3. So for that, I draw a line from here and mark off 3 increments. Then I join from here to there. Then I'm going to get the next ruler. So we have from here, we have 1, here, 1, 2, 3. Now, the rule states that the centroid, the smaller portion should be closer to the bigger side. So this is 1 to 3. This is, oh, this should have been 4. Oh, I should have divided it into 4 equal parts, not 3, because 3 plus 1 is equal to 4. So I made a mistake there. Okay, so the ratio has now been established. I now divide this into 1, 2, 3, 4. So from here, so the rule states that when we establish the ratio which is 1 to 3, which works out to 4 equal parts, the smaller part should be closer to the larger radius. So starting here, you would have been 0, 1, it would have been 1 point, 0, 1, 2, 3. So the centroid would fall here. So here would have been 1, 1, 2, 3. Here would have been 3. So the ratio is 1, 2, 3. 0, 1, 0, 1, 2, 3. So again, the smaller portion should go closer to the larger weight, the larger area. So here is our centroid. Centroid is right here. So here is the centroid. Centroid for these two pieces. These two pieces. Now, once you've established that, the other part is that we now need to establish the centroid between these combined pieces and this. So we have the form we form the centroid for these two pieces, but we now need to find a centroid between this piece and those two pieces combined. So we take it two pieces at a time. So now we're gonna establish the ratio between these two pieces combined as well as this. All right, so here we have it. So we have ratio between A and B ratio C. When we combine the area of A and the area of B, we have 3,200, and the area of C, which is 800. That gives us a ratio of 4:1. So to divide, so now our next step is to divide between this centroid, and this centroid into 5 equal parts to find the centroid for the combined body. So to do that, I'm gonna divide the line. So I'm gonna use my pencil to divide this line between here to there. I'm gonna draw a line here, then mark off 5 equal parts. Alright, so I'm gonna join this center to here. If we're using AutoCAD, what we'd have done would be to draw a line from here to here, then type divide, enter number of segments 5, and we'd have gotten those. So my move now is to okay, that part is now done. Now the ratio is 4:1, and of course up here is a larger part. So we're gonna go down 1 unit from here. Oh, but what you have discovered? We didn't need to go through all of this. The centroid is where this was established, right? Because this is the same weight as this, same weight there, same weight here. So the centroid is right here, right here. Where the centroid for this form, that is where that is. Yeah, so here is the centroid for the entire body. Yeah, right here, centroid for the entire body. And the centroid for the entire body now would be located at, so let us draw a line out here, draw a line here, and one here. So we know that, and from here we probably should use a red. So the height of this would be and this distance is 45, 4, 5. So the centroid here is 45 on the y-axis and 40 on the x-axis, as this is symmetrical. So the centroid here would fall right here, symmetrical. So centroid, so centroid is located at x 40, y 45. So this is our centroid. Yep. Our centroid is located here. From here, it is located on the y. It is located at 40, which is half of this, and at 40 from and 45 on this. Thank you for watching, guys. Hope this video assists.